Welcome to solverfy.
So this question is asking us to give the structures for each of the following aromatic hydrocarbons. And whenever you're writing the structure for a given hydrocarbon, the first thing you want to do is you want to break down the name of that hydrocarbon into its different pieces and determine what those mean. So for part A, we see this O right here, and this stands for ortho, which means that the substituents on this hydrocarbon are going to be right next to each other. They're going to be on neighboring carbons. This part right here means that there is an ethyl group. And toluene means that we're going to be starting with a benzene ring that has a methyl group off of one of the carbons. So when you put the three pieces of this name together, we're going to have a benzene ring with a methyl off of one of the carbon and an ethyl group off of the carbon that is adjacent to it. So you're gonna have to forgive my drawings. My benzene rings could probably use some work artistically, but we'll put a methyl group off of one carbon, and because this is an ortho, we're going to put our ethyl group off of the adjacent 2CH3, and then that lovely fail of a hexagon is my benzene ring. So that is the structure for part A. For B, there looks like multiple parts, but we'll again break this down. This P right here means para. And so a para means that substituents are going to be on opposite ends of the benzene ring. Di means two. So there are going to be two tert-butyl groups on opposite sides of a benzene ring. So I'll start out with my benzene ring. And because this is para, I'm going to put my tert-butyl groups on opposite sides. And there are two of them. And so a tert-butyl group is a carbon with three methyl groups connected off of it. So that is going to be my structure for para-di-tert-butyl benzene. Start with my benzyl ring, and I have two tert-butyl groups on opposite ends of the ring. For part C, we have meta-diethylbenzene, and meta means that we're going to have two substituents with a carbon between them. So we're going to have two ethyl groups with a carbon between them on a benzene ring. So I'm going to, again, draw my benzene. And then I'm going to put an ethyl group here. An ethyl group is just a CH2, CH3. I'm going to skip a carbon, and I'm going to put another one off of this carbon. And that is my structure for C. The last one, you'll note that A through C ended in benzene, so our root was a benzene ring. But in this case, the root is butene. So this one that we're going to draw in part D is actually an alkene, and it's going to be a 4-carbon chained alkene with a double bond off of the second carbon and a phenyl group off of the first carbon. So to draw that, I'm going to start with my first carbon, and I'm going to have and put my phenyl group, which is what we call a benzene, when the benzene itself is a substituent off of another compound. 2, and then I'm going to draw my second carbon, which is going to have a double bond. And because this is butene, this chain is going to have 4 carbons total. And so just to review, that is 1 phenyl 2 butene, with my phenyl group off the first carbon, my double bond off the second, and 4 carbons together in the chain.